and most likely,
You don't go into school.
we're not going to have to go. We're not going to have to do. I don't think we'll need to do every single example problem in this, because I have a feeling that you're going to get an understanding or get the hang of how this works, and we'll move on. Because again, as I've said before, I put more examples in the notes than we probably need. Because again, if y'all get it in 3, you're not going to better understand it with 10. So we're going to go through some of these here. Now, the first thing we're going to look at is the zero product property. Zero product property. Now, if I gave you 2 expressions, A and B are our variables. And if we multiplied them together, and I told you that their product is 0, what would we say the value of A or B had to be? 0. The only way I can multiply 2 things together and get 0 is if one of them is 0. Yes? The zero product property. If the product of 2 expressions is 0, then one or both of them has to be 0. That's all the zero product property is. So if we can rewrite a quadratic as 2 things being multiplied together, that's what we've been doing with factoring. We factored and got 2 things being multiplied together, and it equals 0. One of them must be 0. That is the nice thing about the zero product property, is if I can rewrite the equations as things being multiplied together, set them equal to 0, and we are done. So the main thing with the zero product property is this here. Now, it doesn't have to be specifically 2. We picked 2 just to make it look a little bit nicer, because we could have 10 things being multiplied together equals 0. One of those things has to be 0. And again, when we're focused on the product, we're more focused on the ones that we can make be 0, our variables that are a part of the expressions, not so much our constant numbers. We'll see that here in a minute. Questions on zero product property? So this is our first example. We're told that k plus 1 times k minus 5 is equal to 0, yes? I do have 2 things being multiplied together equals 0, yes? So one of these 2 must be 0, yes? So this is telling us that either k plus 1 is 0, or k minus 5 is 0. Because if the expression, the value of k, if I plug it in, and that it makes k plus 1 be 0, then the whole equation, that side of the equation, will become 0. Same thing is true with k minus 5. If I plug a value of k in, that will make k minus 5 be 0. That whole side of the equation becomes 0. Questions on this so far? Now we just need to solve. K plus 1 equals 0. Well, first thing we can do is subtract 1 from both sides, because 1 minus 1 is 0, telling us, keep color scheme, k equals negative 1. Questions on the first part? Are we ready for the next part? So we need to solve k minus 5. So here we would, almost, plus 5. Because negative 5 plus 5 would be 0, leaving k by itself. And 0 plus 5 is 5. So k equals negative 1 and k equals 5. Those 2 values of k will make the function be 0. Now, say I wanted to check it, because every now and then we do get solutions, they don't look like they're right. I feel like we've had that at some point. we can check these. Now to check them, all I've got to do is take the solution, so -1, and plug it back in for k, because our first one was k plus 1. So we'd have -1 plus 1 times -1 minus 5. And we should get what? It does indeed give us 0. We can do the same thing with -5. -5 plus 1 times -5 plus 5 is 0. So those two are indeed our solution. Questions on this here? We like this so far. Okay. We're ready for the next one. Well, this one's kind of nice because we already do have two things multiplied together that equal 0, yes? So that means one of these two must be 0. Either 2m plus 3 is 0 or 4m plus 3 is equal to 0. So we're still on that first page. Yep, found it. Yeah. Yeah, I need to fix that. I think the funny thing is if you look at last year's video, I probably said the same thing. Future problem. Questions on this so far? So if we look at the one on the left, 2m plus 3 equals 0. To solve for m, the first thing we would do is subtract 3, minus 3 from both sides. As our 3 minus 3 would be 0, leaving 2m by itself. 0 minus 3 is -3. What would we do next? Divide both sides by 2. Telling us that m is -3/2. We can leave it like that there, because -3/2 really doesn't reduce any further, because if we could reduce the fraction in simpler form, we would reduce it, but that is as simplified as it gets. Outside of changing it from a fraction to a decimal. Fraction's fine, we can leave it. Let's look at the other one, 4m plus 3. First step would be to subtract 3, telling us that 4m is equal to -3, or 3 minus 3 cancel out, and 0 minus 3 is -3. Our next step would be to divide by 4, telling us m is -0.75 or -3/4. I will take either answer. I will take it in decimal or fractional, or if you want to put it as a mixed number, I will take it as a mixed number. Because -3/2 is -1 1/2. As long as it's the correct answer, I will take it in any form. Questions on this here? We ready for the next one? Yes? So this one here, we do have two or more things being multiplied together to equal 0. Yes? Not quite. We have three things being added together. I need two things being multiplied, yes? Or two or more. But we can get there by what we've been doing most of this week. Factoring, yes? Because what we'll need to do first to solve this is, one, get it equal to 0. We're already there. Then we're going to factor it. So if I factor the x squared plus 10x plus 21, again, our first step in factoring is to find the greatest common factor if there is one. Is there one here? No. We move to step number 2, our two sets of parentheses with 3 spaces. And we still have the equal 0 because we're still solving. We're just applying the factoring to that one side. Now we need to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here our third term is positive, so the signs are the same and match the sign of the middle term. Plus and plus. Now we're going to plug our factors in. Hang on, especially if you're writing in pen, on where we check, because I'm going to make a statement here in a second. Factors of x squared and 21, because there's nothing too complicated, but it'll make sense once we get there. Now, factors of x squared are x and x. That's the only factors we have for x squared. 21. We have 1 and 21 and 3 and 7. Which ones do we want to check first? 3 and 7. Doesn't really matter for this one here where we put it, so we'll put 3 and 7 in. Now, we do need to check and make sure we got it set up right. But is this problem finished once we finish checking? No, we still need to solve. We're going to keep going down the page, yes? So when you check, especially with this here, we can still do our check step, but I would probably do it off to the side. I would do it to the side of the page, not directly underneath, because we still have to work the problem. We still have to solve. Does that make sense? That way we don't have our check and then everything else right there all in the same spot. So we can still do our x times 7, which is 7x, our positive 3 times x, which is plus 3x, which is equal to 10x. Because also the check is more just to make sure we got the correct factors more than anything else. It's not really, it is and isn't a part of the problem. We're doing it to make sure we have it set up correctly. We do have the correct factors. That's about it. Questions on this so far? Now do we have two things multiplied together that equal 0? Yeah. So one of these two must be 0. Either x plus 3 is 0 or x plus 7 is 0. For x plus 3, we're going to solve for the value of x by subtracting 3. Our 3 minus 3 is 0. Leaving x by itself. 0 minus 3 is negative 3. So one of our solutions is that x is equal to negative 3. We can look at the other one, x plus 7. And the first thing we would do is subtract 7, because our 7 minus 7 would be 0. Getting x by itself. And 0 minus 7 is negative 7. And that's it. Again, if we wanted to plug this in, we could. Parentheses negative 3 squared plus 10 times negative 3 plus 21 is just like we wanted. We can do the same thing with negative 7. Now, I will say, especially when you plug this in, make sure to have parentheses around that x squared term, because here, if you don't put the parentheses around the negative 7 squared, it will not give us the correct answer, because it doesn't see it as negative 7 being squared. It sees it as negative 7 times 7, or negative space 7 squared. We need the parentheses for it to understand that we're multiplying the negative and the 7 by itself. How do we feel about this here? We good with this here? Kind of. We'll do some more. Let's look at this next one. Is it equal to 0? Yes. We can move straight into factoring. It has a greatest common factor of 4, yes? So we can factor a 4 out of each term. And when we do that, we're really just dividing each term by 4. 4x squared divided by 4 is x squared. Plus 20x divided by 4 is 5x. And negative 24 divided by 4 is negative 6. So 4 times x squared plus 5x minus 6. So we have move on to step number 2, our 2 sets of parentheses with 3 spaces. Third term is positive or negative? Negative, because the middle term is positive, but the third term, the sign in front of it's negative, so it would be negative third term, so the signs are opposite. Yeah. Positive, negative. Questions on this here? Now we need to find the factors of the first and third term. Factors of the first term are
1 and 6.
x and x. Yeah, and the factors of 6,
1
1
and 6 and 2.
and 6, 2 and 3. Which one do we want to try first? 2 and 3. And then we'll check this here. X times negative 3 is negative 3x. 2 times x, positive 2 times positive x is positive 2x. And negative 3x plus 2x is negative x. Is that the middle term we wanted? Now we could switch the 2 and 3, and that would give us a different middle term. It would actually be positive x, not negative x. And the reason for that is because what's the numbers in front of x? 1 and 1. Yes, they're the same. So if the numbers in front of x are the same, switching that constant term isn't going to really change much. Now, I'll show you that here. You don't have to write this next part down because we're going to have to erase it anyways. Because if I do switch the 3 and 2, we get x times negative 2, which is negative 2x. Positive 3 times x, which would be plus 3x, giving us positive 1x. So really all it did was change the signs of 2 and 3. Now, if there had been a number in front of each of the x's that wasn't the same for both, then it would indeed change the number. Questions on this here so far? All right. Well, now we need to try 6 and 1. X times negative 1 is negative x. 6 times x is going to be positive 6x, so plus 6x. And negative x plus 6x is positive 5x. Is that the middle term we wanted? So 4 times x plus 6 times x minus 1 are our correct factors. Questions on this so far? So do we have 2 or more things multiplied together to equal 0? So what has to be 0? Well, x plus 6, yes? Has to be 0. And the other is x minus 1, because I can plug a number into x for x plus 6 to get it to be 0, yes? I can plug a number into x minus 1 that will cause it to be 0. Is there anything I can do to the 4 to make it be 0? Well, no, it's just 4. It's just a number. So at this point, we're pretty much done with the 4 because the only things that we can actually make be 0 are the x plus 6 and x minus 1. Now we just need to solve. For the x plus 6, we would subtract 6 from both sides, telling us x is equal to negative 6. X minus 1. That's it. Because really, once we get a handle on factoring, this really doesn't add too much to it. Because we just get it factored, set it equal to 0, and solve. That's it. Questions on this here? We're ready for the next one. Because the next one does look a little bit different, would we say? All right. So, what's the main difference with this one here? There's only 2 terms. Which term are we missing? Because we have the n squared term, yes? We're technically missing the second, the middle term. Because we technically do have the first, we do have the third. We're missing the term with just n, the variable to the first power. And we do have it. It is, because it is there, it's just 0 in. Now this here, let's factor out the greatest common factor first, which is 3. 3n squared divided by 3 is n squared. 75 divided by 3 is so we get 3 times n squared minus 25 equals 0. Now, n squared minus 25 technically is a special type of quadratic. We call it a difference, being subtracted, of perfect squares. We'll talk about it more on Monday. Specifically, there's a special way that these factor every single time, and it works out quite nicely. But this here is factorable. So we still have our 2 sets of parentheses with 3 spaces. And it still does equal 0. Our third term is our 25. Is the 25 positive or negative? Negative, so the signs are opposite, because the third term is negative. So the signs are and minus, plus and minus, opposite signs. Factors of the first term, factors of n squared are n and n. Now the factors of 25, our third term, is 1 and 25, or 5 and 5. 5 and 5 might be a little bit easier to check first, because even if we do flip those 2 5s, it gives us pretty much the same thing. It doesn't change anything. Let's check and see if this is the correct setup. Our first one is n times negative 5, which is negative 5n. Positive 5 times n is positive 5n, which does equal 0. So n plus 5 times n minus 5 are the correct factors. So it's set up in just a way that the middle term cancels out. This is part of the reason why we call it a difference of perfect squares. It factors this way. Questions on this here? We'll find a nice little shortcut to factoring these that'll make these nice. Since we have 2 things multiplied together to equal 0, one of these must be 0. For our n plus 5, we would minus 5. Telling us n is negative 5. For other one, we would add 5, telling us n is equal to 5. Questions on this here? How do we feel about these here? We feel good with this first set, yes? Do you need to see another one like those? Not so much the difference of perfect squares, but the others that we looked at on that page. So we feel good with those there, yes? Let's look at problem number 8. Because it is a little different. Not much, just a little.
Oh.
What's different with this one here?
It's not equal to 0.
It's not equal to 0, yes? So what do we need to do? We need to make it be. So how can we make this be equal to 0? I wouldn't divide, but we can. Yeah, we can move it to the other side. I don't know why I heard divide.
That was me.
Okay. Because we can divide by 3, and that actually, there is a way, not so much 9, but 3 does work. But we just need to move it. We can add or subtract it to get it to the other side. Because negative 9p plus 9p is indeed 0. Now 9p It does not like terms with 3p squared or negative 120. So we're going to write it in standard form. And according to number theory, we write things in decreasing order of powers and in alphabetical order. So p squared, p, number without a variable. And it's going to be better to put it here when we add it over. That way we're not having to rearrange it. So, questions on this so far? So really at this point, is it any different than what we've just done? No, same exact thing. Then we move to our next step, our greatest common factor. And the greatest common factor here is, so we can factor it out, which would leave us with p squared plus 3p minus 40. Once we factor the P3, not P3 out, we have step 2, our 2 sets of parentheses with 3 spaces. We're going to find the sign. The third term is negative, so our signs are and minus. They're opposite. One's going to be positive, one's going to be negative. Factors of p squared, p and p. Factors of 40, we have a few. 1 times 40. 2 times 10. Not 2 times 10, 2 times 20. 4 times 10. 5 times 8. 5 and 8. Which one do we want to go first? 5, 8. And the last thing we can do is check. P times negative 8 is negative 8p. 5 times p is positive 5p. Negative 8p plus 5p is negative 3p. That is the middle term we wanted, yes? Well, yes and no. It is the correct number but wrong sign. Since we do have the correct number but wrong sign, we just need to flip the signs. Which if we check it again, we would have positive 8p minus 5p is positive 3p. Questions on this here? Well, there's only, now we need to solve, because for us here, either p minus 5 is equal to 0 or p plus 8 is equal to 0. For our p minus 5, we would add 5 to both sides, telling us p is 5. For our p plus 8, we would subtract 8, telling us p is negative 8. Questions on this here? Do we feel comfortable with this here? Okay. Do y'all want to see another one? Or do we feel comfortable with this here? Okay. Your assignment is a worksheet. You're welcome. You're welcome. I mean, if you want to do it 4 times over, or 3 times over, you can.
I'm gonna have to.
4. Yes, ma'am. Yes. So that's it for today. 11 questions.